Hi, welcome to today's Active Archive Alliance webinar titled Active Archive for a Sustainable Planet. I'm Meredith Bagnulo, Administrator of the Active Archive Alliance, and with me here today is Rich Gadomski, Head of Tape Evangelism for Fujifilm, and Sean Brumet, Tape Evangelist and Strategist at IBM. Welcome, Sean and Rich.
Thank you, Meredith.
Thank you very much, Meredith. Great to be here today.
Great. Today's agenda, we're going to talk a little bit about the Active Archive Alliance and Active Archive topology, the reason to move data, energy advantages of tape, and energy advantages of tape systems. Before we start, I'm just going to give a little bit of background on the Active Archive Alliance. We were founded in April 2010, and our main purpose is to be a collaborative group of companies that promote simplified online access to data throughout its life cycle. And we're aligned on education and technologies to meet the evolving requirements of data archives. We currently have 16 members, including Fujifilm and IBM, who are here today for today's discussion. I'm going to hand it over to our speakers and start with the questions. So Rich and Sean, why Active Archive?
Well, thanks very much, Meredith. I'll jump in on this, and Sean, please join me. But today, users are leveraging Active Archives to gain efficient access to data throughout its life. So data moves, by policy from expensive tiers of storage to economy tiers of storage as needed. But again, transparent to the end user, and Sean will explain that in the topology. But I'll say that Active Archives are compatible with any storage type, whether it be tape, disk, flash, optical, cloud. So again, it's for managing the appropriate use of storage tiers to minimize cost, but also minimize energy consumption, yet maintaining user accessibility. So really, and another key feature too is that organizations can deploy Active Archive to strengthen cybersecurity, data protection, protect against ransomware. And again, Sean will show that. So we are a vendor neutral, trusted source of information on how to set up Active Archives and leverage the intelligent data management that it provides.
Rich, that was a good overview. As we look at the topology, I think it's important to remember that unlike compute environments where compute power comes in, it goes out, compute gets more powerful in a smaller structure and therefore more density, as storage density increases, the storage itself continues to increase. It never goes away like that compute power. So as data is created and users and applications need access to that data, and we're deriving more value from it, it begins to tier out. And some of it tiers out into different tiers of HDD or high performance flash when needed, for instance, AI and analytics. But IA, that information archiving, is so important within the structure because it creates that value. So as data tiers, data is going to move out of those hot zones through the warm zones, and eventually, according to IDC, Gartner, and others, approximately 60% of that data, if untouched after 90 days, is never touched again unless it's pulled back for a specific purpose, which means tier that data out, create value by reducing the overall cost, move it into tape infrastructures, and utilize it within your hybrid infrastructure, whether it is simply to retain for regulatory or to air gap for that all-important cyber resiliency, something that we see every single day in the news. Another company gets hacked. And Rich, I think you had made a good point about S3 being in here earlier. Can you expand on how that S3 works with a hybrid there?
Well, definitely cloud. Yeah, as I mentioned earlier, cloud is definitely part of the picture. It can be. It's not just about on-prem, disk, tape, flash, optical, but Active Archive can leverage either private or public cloud via S3. So it really gives maximum flexibility to what users are doing today.
And I think the last part of that hybrid infrastructure story is that when data goes to the cloud, it's not that panacea. It doesn't just go into some magic zone. Large scale are utilizing these tiered concepts to drive data between their HDD infrastructures and their tape infrastructures. So it's a proven concept and it continues to work.
Yeah, and Sean, I'll just add what I like about Active Archive is, where the files are stored pretty much becomes transparent to the end user. As I mentioned, it's moving by policy at the right time, and it's going to the right place at the right time at the right cost, and thereby minimizing cost as the frequency of access goes down.
Absolutely.
All right. So, why move data? Very simply stated, we have too much of it. We can't delete it, and we can't maintain it on expensive, energy-intensive primary storage. There's really no need to do that, as we'll see in the next slide. But this is data from IDC, Storage Sphere 2021, and they're predicting between 2015 and 2025 a 27% compound annual growth rate. Industry going from 2 zettabytes of, now this is persistent data that needs to be stored. The data sphere itself is much greater, but for the amount of data that actually gets stored, we're talking 2 zettabytes 2015 to 11 zettabytes in 2021. Still a tremendous amount of data. Just a single zettabyte is 55 million LTO9 tapes or 55 million 18 terabyte HDDs. So 11 zettabytes, still a massive amount of data. 27% can be considered pretty conservative. Current or more current reports than this from 2022 are saying 30, 35, 40, 45%. We know that the hyperscalers are growing at 50%. So this is a challenge for enterprises of all sizes, all shapes. We have a tremendous amount of volume of data, very high rate of growth, and the value of that data is increasing. We can apply analytics to it, derive competitive advantage. So we want to keep that data for longer periods of time, and we want to maintain access to it. And that's the beauty of Active Archive. So I think Sean touched on this, but after 30, 60, 90 days, approximately 60% of data quickly becomes inactive and therefore becomes a candidate for archival storage. So it should move from primary active layers of storage, what Sean called hot layers like SSD and HDD, to economy layers such as tape systems. So frequency of access goes down dramatically, yet that data has value, can't be deleted. And we want to maintain access to it. If you ask most end users, hey, can we take your data offline and store it on a shelf somewhere? They'll probably say no. They'll probably want you to, they'll want to maintain access to it. So Active Archive allows you to maintain service level agreements by providing access. It's just moving behind the scenes to cost-effective tiers of storage, but end user accessibility is maintained without IT intervention.
Rich, if we can go back, I really would like to emphasize the value of data line, because it sits there in strong bold, but what does that really mean to the client or to those that have to store the data? It essentially is saying that, an assumption that data just kind of loses its value along the probability of access is just not true. In the 1 to 10 year time frame, that increases to an amount that is equal to the value at time of creation. And therefore, long-term archival data in the economy zone is critical to recognizing the value later on.
Absolutely. Yeah. So, as needed it's hard to predict when data will be needed in the future, whether it's for a compliance, a regulatory issue, whether it's for future monetization, in media entertainment industry. If a celebrity all of a sudden is in the news, you want to find some video clips from that person. So you never know. Yeah.
There you go.
Okay.
Great examples.
So let's talk about the energy advantage, specifically of tape. So as that data moves from expensive tiers of storage to economy tiers of storage, you also get the energy advantage. And sustainability has become a huge issue today. I used to try to convince people of climate change and global warming, thinking to some of the trade shows I presented at a couple of years ago, but no need to do that today. The evidence really is all around us. You look at the extreme weather patterns we have, the forest fires, floodings, just the changes in global warming are pretty undeniable. So sustainability is becoming a bigger issue today. How much energy is consumed by the IT industry is under the microscope. And what we find, this is a report done by Brad Johns Consulting, and Brad studied the HDD systems versus tape in terms of energy consumption. And this is just in the usage phase. So based on 10 years, storing 10 petabytes with 35% annual growth, he found that a tape solution would produce 383 tons of CO2. That's an 87% reduction compared to if all that 10 petabytes were stored on HDD systems. It would produce over 3,000 tons of CO2. So 87% less energy consumption by tape systems, and therefore 87% less CO2 production. So pretty significant reduction, especially when you consider that after 30, 60, 90 days, the data goes cold. So why keep it on energy intensive tiers of storage? And again, that's one of the things that Active Archive really helps you with.
And, Rich, as we look at that, I think it's also safe to say, and I remember coming up in the Brad Johns report, that this is really regardless of how that energy is produced. And as we move to infrastructures for energy creation that are around sustainability and continuous availability may not be there, lowering that overall amount of energy by 87% is going to be significantly impacting, right?
Oh, absolutely. I mean, it makes a big difference, really, at any scale, at any enterprise, any organization. So, when it comes to renewable energy, it's great. And Fujifilm is a big fan of renewables. We use it ourselves in our own factory. But when you look at the broader IT industry, it's not the answer. It can't come online fast enough or cheaply enough. So conservation has to be part of the equation. So in as much as any organization can reduce the amount of energy they're consuming, that's going to be a big contributor to CO2 reduction.
Great point. Thank you.
And then when we continue to, now this is an additional report that was done a little bit later. So the previous slide was from November 2020, just looking at the usage phase. This August report from this year looks at the total life cycle. So it now looks at CO2e or CO2 equivalents, because it's starting to measure greenhouse gases other than CO2 that are produced primarily in the production and raw materials phase. So this is total life cycle from what I call cradle to grave, from raw materials, production, distribution, usage, and disposal. And again, this is a 10-year study looking at 100 petabytes. And what Brad has found that in the total life cycle, there's a 97% reduction in CO2 when you're using a all tape system compared to HDD. Now, the bar in the middle contemplates an active archive where 40% of your data is still on primary storage, say HDD in this case, and 60% has moved to tape. You still have a dramatic savings, a reduction of 58% in CO2e. So this is really getting the right data in the right place to reduce costs, maximize energy efficiency, reduce CO2e in this case. All right. And then Sean, you want to talk about TCO?
Yes, definitely. So in that cradle to grave, it's not just about CO2e, although some could argue that CO2e is more important than the dollars to spend on a solution. It's important to understand how the proper migration of data creates value. And if we take 100 petabytes, and this is a scale example because big numbers are easier to understand and calculate very quickly. This applies across pretty much all scales except for maybe the 8 terabytes you have sitting in your house. So if we're going to deploy 100 petabytes, a 10-year total cost of ownership, which includes things like maintenance and energy and cooling and replacement of parts, a 100% HDD solution may run in the scale of $17 to $20 million over that 10-year period. When you move 60% of the data to tape in an active archive, so again, this data is still online and ready to go, you instantly cut to almost 50%, 46% reduction in the overall cost to maintain the environment. And tape is pretty easy to use within active archive and integrations of S3, or should we say object storage and file systems. And as data cools down even more, so you take that 100 petabytes from 10 years ago that's now all pretty much cold at the 7-year mark, 100% of that data on tape is only around $4 million, $3.8 million, or a 78% reduction from the HDD. Value instantly comes from the total cost of ownership, but also from the value we can now get in pulling back that data in that active archives, because somewhere that tape is still connected to an HDD within an active archive, unless it's just serving as an air gap. And if it's just an air gap, this is much like what the entertainment industry does with films. And I always like to bring up Star Wars because they remade it in 4K. And all of a sudden, it was a completely different movie from a standpoint of understanding certain things. So there's a lot of value to be derived from proper tiering of data over a long period of time.
Sounds good. And we know that TCO is a major driver of decision making, especially in terms of long-term strategy for how to manage not only the data volume, but the data growth that's happening in the industry today, and energy as well, also a part of TCO. So
right, it's all builds on each other. And I would start off this by reminding everybody, everything we talk about is cradle to grave. I love the way Rich puts that together. But if you start off with a stronger cradle, in other words, you implement from a point that's much lower in a environmentally impacting, because remember, sustainability is the environment, it's the social impact, and it's the financial impact, right? How this works as a total. And when we look at storing long-term data and we break it down into CO2e, the equivalent of CO2 over that period of time, we've talked about energy, the huge amount of energy that goes into it. But from a fundamental, you lower it from the beginning with embedded carbon, comparing probably what's one of the densest, most deployed infrastructures in OCP, Open Compute Project, a Bryce Canyon supporting 10 petabytes of data that's usable, generates around 397 total metric tons of CO2e in a 10-year period. And this includes refreshing the environment, because you're going to do that. Hardware begins to wear out. HDD cycles show fallout over a 9 to 10-year period. And compare that to, say, an IBM TS4500. And in this instance, it's an IBM TS4500 just as a reference. You're only going to be around 78.1 metric tons of CO2e over the entire 10-year period. And that includes energy, but most of all, what you start out with a much lower embedded carbon footprint. And that ultimately leads to a tape library being 80% less in CO2e over that 10-year period.
Sean, I've been reading a little bit about SSD versus HDD, and seems like there's a little bit of conflicting information out there. But how does the HDD stack up against SSD in terms of energy consumption, and is it similar or more or less than HDD?
Well, it's an interesting point. From a base, in other words, if you took 10 petabytes of SSD, there's been some, as you said, kind of some confusing or conflicting information that would say, hey, you know, SSDs use less carbon, or they have a smaller carbon footprint. Actually, not for storing data. In utilization in high performance environments, SSDs do better because you need fewer of them to achieve the performance than you do HDD. But from a raw storage point, there are some very good articles out there that demonstrate that both from an embedded carbon and an energy perspective, power consumption and cooling, HDDs are better than SSDs. But again, it comes down to workload. Just like no one would look at tape and say, well, it's a better CO2e, I'll just put all my data on there. You're going to have those HDDs. It's part of an active archive environment. And eventually, I think we'll see SSDs playing more of a role in an active archive environment as commodity SSDs represent a certain level of value.
Yeah, so there's always trade-offs. Yeah,
there is.
Okay, so I think that brings us to our last slide. So just in terms of a little bit of a wrap up, and help me out, Sean, but I think that it's pretty undeniable, that organizations, enterprises of all shapes and sizes are facing large volumes of data today. They're facing significant data growth. The value of data is increasing. So we do need things like Active Archive, which are, in fact, modern strategies to address those challenges. And I always like to say it's about getting the right data in the right place, at the right time, at the right cost, and at the right energy profile. Agree?
I agree. And if I can add one thing to that overall, there is no industry, no workflow in the world today outside of going fishing or hunting that is not engaged in the IT environment. Surveillance, digital surveillance is not about cameras and looking at what's happening. It's about storage of data. Healthcare is about storage and utilization of data. It doesn't matter. So every industry has the challenges that you just outlined, Rich, in putting data in the right place at the right time for the right time period.
Yeah, that's awesome. Meredith, I hope that addresses the topic, and thank you very much for hosting the webinar today. And we look forward to joining the audience again next time.
Definitely.
you.
Thank you.
Thanks, Sean.
Thank you. It's been great. Yes.
Thanks, Meredith.